right, it's wonderful to be with all of you again. My name is Jason Shern. I am the field CTO at Cognite, and welcome to the final episode of our AI Office Hours webinar series. A little bit of reminder of what the series has been about for the last 3 weeks. We've been discussing the basics of industrial AI agents. We've talked about laying the foundation for them to work, things like knowledge graphs, contextualization, and how to pick a large language model. But today I'm going to talk a little bit more about bringing it together and speak a little bit more about how this comes together for agents. And so, in a previous conversation, we talked about the importance of being able to have a knowledge graph and a large language model to help you get deterministic, reliable responses from generative AI in an industrial setting. The reason that is important is that these large language models are probabilistic in nature, meaning they're going to choose the most likely answer to your prompt or to your question. And so if we can provide information, typically proprietary industrial information within your business, as context to this large language model, I'm providing it a deterministic base of data to answer my question. And when I do that, I get more reliable responses, but it also allows me to know how it came up with the answer so that I can verify and validate it. And so something that we learned early on is that within an industrial setting, the standard chat-based interface for using generative AI was insufficient in several aspects. First of all, this ask me anything, I'll give you any answer type format led to a lot of hallucination and made it really difficult to rein in the creativity of the large language model and accentuate the reasoning engine of these large language models. And what's really been exciting over the last several months is this advent of AI agents. And an AI agent is composed of several parts. But what's exciting about them is an agent allows you to take this ask me anything, I'll give you any answer type framework for interacting with generative AI and narrow it down to a specific task. And so by narrowing it down to a specific task, I get 4 kind of key benefits. One, I'm able to provide very specific instructions to the large language model in how to answer my question or my prompt. And that significantly reduces the amount of hallucinations you receive and sort of forces it to follow a set procedure or a set process that is typically a standard way that you would like the large language model to answer. Second, it gives me the opportunity to choose the foundation model that I want to use in answering my prompt. So rather than using one single generic large language model, I can select the best language model for the agent that I'm using at that moment. And so I might have agents that work sufficiently well with a small language model. I might have agents that work well with large language models like OpenAI or Cloud or others. And then I might have some specially trained language models that have been trained specifically on proprietary data within my business that I use to answer my prompts for a particular agent. And then third, I'm able to provide specialized context to that agent. So I can say, in answering this prompt, I would like you to use this information. And by doing that, again, we're able to tell the large language model, don't answer the question based on what you think you know. Answer the question based on the information I'm going to provide to you. And then finally, we can provide a lot of specific instruction to the large language model about how to deliver the output. So I can give instructions on how to perform the task. I can give it, I can assign a specific language model to use that's going to be best for this type of task. I can give it specific context information, proprietary information for my company in order to answer the question, and I can tell it how to get that answer in return. And so by defining an AI agent in this way, I now have the flexibility to get a higher level of deterministic response. I can get information that is verifiable and repeatable, and I can ensure that these things are acting in a way that aligns to the security and infrastructure of my business. And so building an agent requires that you have the ability to do this prompt engineering, define the instructions, select the language model that you would like to use, tell it what type of information to utilize in answering my question, and then explain how that output should be returned to you. And that is what we're building at Cognite right now. Our Atlas AI agent workbench provides a low-code, no-code environment for you to do those things, to be able to provide the prompts, select the language model, as you learned from Viva in a previous conversation, give it contextualized content from your corporate knowledge graph, and then architect the output that comes back from the large language model so that you can reuse that in other applications and in other settings. And so this is pretty exciting. And so being able to have those tools allows us, Cognite, to develop out-of-the-box agents for everybody using Cognite Data Fusion, but also allows you to develop your own agents using the information that you've contextualized within your business. Something else that this enables is what we call orchestration. So in a typical ChatGPT type interface where I'm just using a chatbot, it's very difficult to integrate that into existing processes, systems, and functions. But when I'm developing an agent, I can develop that agent to be run interactively with the user as part of an application or as just natural language prompts. But I can also make that agent work programmatically so that I can call this agent as a function, have it perform its tasks using generative AI, and return the result to then be used in another piece of the solution. And so that type of agent orchestration is incredibly powerful. It allows me to coordinate different agents together, to assign specific activities to an agent as a task. It allows me to monitor and control how these agents are being used and their performance, and then allows me to integrate them in programmatically into the rest of my existing systems and business functions within the company. And so once you have an ecosystem of these agents, you can start integrating them together to work seamlessly. So a good example of this would be, for example, that we might have physics-based simulation models that allow me to do predictive analysis of different aspects of our operations. I can use this for predictive failure, predictive maintenance, and other tools. Well, if I have an agent that I have constructed to know about these simulations and these other machine learning tools that are available to me that might be physics-based, I can have that agent programmatically call those simulations or physics-based machine learning tools, and then return the results into the agent that I can then process further using large language models, generative AI, and other tools. And that type of orchestration opens up the power of generative AI to actually leverage existing systems and capabilities within your business. So Atlas AI is bringing all of these things together, what Vipa and Murad and myself have been talking about, to be a complete solution for you within your environment. And so when we started off this journey, we thought that, number one, any large language model would be sufficient. We thought that retrieval augmented generation as a way to find proprietary data in your environment and add it to the context window would work for all use cases. And we also thought that that sort of ChatGPT style interface would be the way that most people interact with generative AI. And we've learned over the last several months that actually we need to be able to use the right language model for the task at hand. And I think Viva talked a lot about that in a previous session. We need to be able to use the power of your industrial knowledge graph to find information for context. That allows us to find information that is more specific, that adheres to your security and access control, and is going to provide a more deterministic response from these large language models and these agents. And then finally, the agentic approach of being able to build task-specific agents to address needs within the company is going to be the most productive way forward to scale the value of generative AI within the business. And so that's what we bring together in Atlas AI. This ability to select the best language model for the task at hand, to be able to have seamless access to the semantic knowledge graph that you've built within your company of your proprietary industrial data, and then being able to have an agent workbench that allows you to bring all those things together to build agents that you can then orchestrate and run within your existing systems and processes. I'd like to show a simple example. This is an example that comes from a company that we work with in the oil and gas industry. And they are in the process of constructing a large offshore oil and gas platform. And in that process, they're receiving literally hundreds of thousands of technical documents for the equipment on this platform. And they need to be able to take this information from these technical documents, extract it, and put it into their contextualized knowledge graph for use in their business. And as you can imagine, all of these documents come in a completely different format from every vendor. And it's just impossible to get all of them to adhere to a common format or a common data model to be able to supply this technical information. So what we did in working with this company is we said, look, let's see if we can use generative AI to help us extract this information from the documents and add it automatically to the knowledge graph. So you can see we've started to define the scope of an agent, right? We have a specific task that we would like to go perform, and we want to be able to provide instructions for that task, tell it what information to use in responding to the prompt, and architect how that information should be returned to us as an output. And if we can do that, and we can do that both in a way that can be accessed interactively by a user on demand, but also do it in a way that can be accessed programmatically, then we have the ability to, when needed, take the information from these documents and add them to the knowledge graph as they come in, or we could go programmatically process literally hundreds of thousands of these documents using generative AI to help us find this information and add it to the knowledge graph automatically. So let me show you what that looks like. So this is Cognite Data Fusion. Within Cognite Data Fusion, we've already input these documents that have come from these different vendors, and we want to be able to extract relevant information from these. So what we do is we start by defining a data model for the information that we want extracted. You might already have a data model for this. We're going to build one real quick in this example. And these are valves, and so I'm going to create a data model for these valves. And you can see it's a simple data model. It's simple information we're extracting. But what we're doing is not only defining the information that we want to extract from these documents, we're also providing descriptions to these fields in natural language. Because a large language model can understand this natural language description of the fields and use that to help it better understand what it's looking for in the document to extract the right information. So rather than just saying, I want the tag number, I'm giving it a description that says the tag number includes a space between characters and typically looks like this. And that helps the large language model better identify this information within the document. Now, once I publish this data model, I'm ready to go. So I've already defined my agent. It's called the doc parser. And I go ahead and tell it which documents that I would like it to parse. And I can choose several of them. In this case, I can only choose about 4. And I execute by telling it which data model to use in order to extract information from these documents. And we'll use the data model that we identified earlier and then run it. And now this agent is running in the background using a large language model to take this document, the prompts and instructions that we provided it, and the data model as instructions, and to return to us in output form the relevant information extracted and put directly into the data model to add to our knowledge graph. And I've done this in a way that provides a user interactive experience to validate the information that came back, but I could also call this agent programmatically to see the same results and automatically add this information to our knowledge graph. Hey, great, thank you. I appreciate your time. It's been wonderful sharing some of these great developments about generative AI and the agent architecture that we hope to bring with you with Atlas AI. If you want to learn more about industrial agents, please check out our latest book, The Definitive Guide to Industrial Agents. In there, you'll find a lot more inspiration about what you can do with generative AI in industry, and it'll help accelerate the innovation and success that you have in leveraging these technologies in your business. Please go to cognite.ai. There's a lot of additional information that you can find there, as well as replays from these sessions and more. We do have a conference next week, Impact. It's being held in Houston. We're very excited about this. Unfortunately, we are sold out, but please stay tuned for the content from that conference, which we'll be sharing with you shortly. Again, thank you for watching, and hope that you're as excited about this as we are. Thank you.